Now it's going? Now it's going. Thanks. All right, so 5.3 is all about angles of triangles, okay? Now, on Thursday, you guys got a worksheet, if you were here, and it had all these different triangles on it. And some of you got through it all, some of you didn't, and that's okay. Just practice. And so basically, this is in geometry when we study theorems and names. This is called the triangle sum theorem. You don't have to memorize that. Basically what it means is when you add up all three angles, they should add up to 180. And I know you learned that before, so that should be a bit of review, right? Okay, so this is how we solve it with this example 1, which a lot of you do this in your head. You don't even need to write it down. You're like, oh, I already know. I add two angles, I subtract from 180, I have the answer, okay? But some of you need a clear example, and that's fine. You can write down what you need on this one. The other thing I want to highlight is I did list them as interior angles. Does anyone know why I would even write that? Like, isn't that kind of obvious? Does anyone have any idea why I said that? Nobody? You guys are all half asleep? Why would I even mention these are interior angles? Oh, raise your hand. So I heard something over here. Alyssa?
Because they're on the inside.
Okay, they're inside, yep. But why would I even point that out? It's kind of like obvious, yeah.
Because there's others that are exterior.
Yes, very good. So what I'm pointing at is eventually we're going to do the exterior angles. So we've only done interior angles up until this grade. And now we're going to look at the exterior angles, which a lot of us don't think about. But that's where we're going, okay? So exterior angles of a triangle. Okay? There's a big long proof and theorem that goes with this. But I just condensed it into one little equation for you that you can always use this equation. So write this down. That is a 1, by the way, not an I or an L. And then I'll explain how this works, okay? But this is called our exterior angles theorem, but we're just going to leave off the word theorem today. Exterior angles of a triangle. So we have this triangle ABC with this little kind of piece that sticks out here, and that makes an exterior angle 1. Okay, so the formula that goes with that, it says that the angle of A and the angle of B, when you add them together, they're going to equal the angle 1. Okay? So essentially what this is saying is if you add the two opposite angles from the angle you're looking for, they equal that angle. So what I mean by opposite is if I draw like opposite across this way and that way, those are opposites, right? So that plus that will equal that. And I know some of you were thinking, how did they develop this? Because some of you think that way. And you realize that this piece right here has to add up to 180, right? This is a linear pair, supplement. So that means this is the difference of 180, right? So those of you that were thinking that way, that's where the proof came from. The rest of you who are like, I don't know, I just wrote it down, that's fine. You can be there with us. But just know, when you add the opposite angles of this exterior angle, they will be equal. Okay? All right. Some of you saw this notation on the worksheet, and maybe you didn't know what it meant. But the notation where you have this little m and an angle, that just means the measure of an angle. Okay? So a little side note here. You're going to see a lot of this in your book and on the tests and quizzes. So that little m just means measure. Raise your hand if you already knew that. Okay. So like half. So little m in front of an angle means measure of angle A. Okay, so I want to give you guys a couple examples of this theorem, and then I'll just let you practice. So just two examples of how this works. All right, so the first drawing is another triangle, but this time I put two exterior angles. Okay? So I have basically, you guys see that? Yeah. So I have this triangle L, K, M, and then I drew one exterior angle on the right side, which I call 4, and one on the bottom left, which is 5. And then this particular problem says if the measure of angle 4, which is that one, equals 135, find the measure of angle 2. You guys remember, what does this little square mean again? Right here on K, what does that mean? And it's 90 degrees, right? Okay. So if that one's 90, and they gave us 4 was 135, right? How do I find 2? This is how I find it. So I take the measure of angle 2 plus the measure of angle K, which is up here, and that has to equal the opposite exterior angle, right? Now I just plug in what I already know. Okay, so if I know, do I know 2? I don't know 2. Do I know K? K is 90. And do I know 4? 135. So this is how you set it up. So I say, okay, 2, measure of angle 2, plus 90 degrees equals 135. So far, so good? And then how do I solve for 2? Add, subtract, multiply, or divide. Subtract. Is that what you're going to say, Connor?
Yeah.
Okay. So when I subtract, I should get 45 degrees. So I put extra angles here, and they'll do that because they want you to know what you're supposed to be looking for, right? So they're always going to put extra numbers and extra angles, and you have to decide what are you looking for. Okay? Well, they don't want to confuse you. They just want to make sure you know that you know that you know it. Okay, any questions on example 2? Yeah.
When will we ever actually use this?
All the time. Totally in your math class. Every day. And for the next 8 years of your life. Alright. So, and just think, if you ever aspire to become a math teacher, just like me, use it every day. Today, this is my 4th time using it today. Alright, let's move on to the next example, yeah? Okay. So example 3 looks exactly the same kind of drawing. It's the same drawing, really. This time they're going to give us angle 5. This is this exterior angle right here. And they want us to find this one. Okay, so we know this is 147. They give us that. We know K is 90. We want to find 1. So if I draw these little lines, I can see, oh, that's an opposite, right? Remember, those two added together have to equal that one. So we have measure of K plus the measure of 1 equals the measure of 5. So far, so good. So I can plug in 90 for K. I don't know 1, and I can plug in 147. 90 degrees plus measure of angle 1 equals 147 degrees. Subtract 90, and you should get 57. The nice thing is, when we're doing this kind of geometry and the stuff we did in section or lesson 1, everything was kind of adding up to 180, right? Now, this isn't adding up to 180, but you're still using what you know about triangles, right? You know that 5 and 2 have to add up to 180. So if you're not comfortable using this theorem, then you could at least figure out what 2 is and then work backwards. Okay? But this is kind of the shorter version of that, right? Okay, so the ones that I want you guys to practice in your book are on page 392, 1, 2, and 4. 1 and 2 are just like what we did on Thursday and in the homework, and then 4 is just like this one. Okay? If you need to use a calculator, use a calculator. They're not big numbers, but it makes it go faster. So I'll give you like 3 minutes. We'll go over those, and then I'll give you a few more to try. Make sure you got it.